Okay, good morning, wonderful people. All right, so from where we left off the last time, we are graphing quadratic graphing quadratic functions. And this time we are doing the next part. So we're continuing on with graphing quadratic inequalities. So that is going to be this part down here, graph quadratic inequalities. We're going to go ahead and see if any of them have maximum or minimums, and use the axis of symmetry and the vertex in order to find these parts of the graph. So same thing, create a table of values, and the vertex should be in the middle row. That way we get a really good picture of what's going on. Graph using a dashed line if there is no or equal to. So if you have a less than or equal to, the vertex should be, oh, sorry, I'm reading the wrong one, and a solid line for the less than or greater than symbols. Shade above the line for ones that are greater than, whether they are greater than or equal to symbols. And below the line for less than or equal to symbols. So same rules as the other one, where you graph above or below the line. We are still going to be using our axis of symmetry formula, which is this one right here. And remember, the vertex is on the axis of symmetry. So once you have the axis of symmetry, evaluate your original function for the number you get out of here, and that should give you your vertex. This is the standard form for quadratic equations. So let's go ahead and start working on some of these. So graph each inequality. So first thing we got to do is check it to make sure that it is in standard form. So again, it's x squared, regular x, and x to the 0 or no x. So this one is in order, because I know a lot of times students, they tend to look at the numbers in order. So if they switch two spaces, they put the wrong a and b value in there. So you got to make sure that you're looking at the right ones. So negative b, so grab our b value. Remember, it goes a, b, c when it's in order, which this one is in order. So negative 2 times 2a. And in this case, my a value is 1 because of my first value does not have a coefficient, so it has a coefficient of 1. Negative 2 over 2. And 2 divided by 2 is going to be 1, so negative stays there, so that means it's going to be negative 1. I'm going to mark out my axis of symmetry here, and that means that it's going to be the same on both sides. So it's going to be the same on both sides of that line. It's going to be the same shape. So that way I know if it doesn't match up, something must have happened, something must have gone wrong. All right, so now we need this number to be the middle number, the one that we put in there. And now we need to pick some values below it. Actually, below it would be negative 2, negative 3, negative 4. And now to go up. So I picked 3 spaces down and 3 spaces over. And with some of the other functions like absolute value functions, you could probably get away with guessing. Here, if you guess, you're going to have some areas that will be off the graph. So you may not be able to get them exactly where you need them. So let's go ahead and start evaluating. Okay, so we need negative 1. So I'm going to plug in, first off, I'm going to get my equation. So we have x squared. Oh my gosh, can't write today. Okay, so x squared plus 2x minus 2. And now we just got to plug in different numbers. So let's start with negative 4. Plug in negative 4 and evaluate it. Negative 4 squared, so that's negative 4 times negative 4. That's going to be 16. 2 times negative 4 is negative 8. and minus 2. So 16 minus 8 is 8, and 8 minus 2 is 6. Or I could also add both of my negative numbers. So this is negative 10. Actually, that would be 6. And in my opinion, that way is a little bit better because you're less likely to run into something. So I combined both by negative numbers. So I got negative 8, negative 2. So that makes negative 10. So that's 16 minus 10. And again, you're less likely to make a mistake if you are, like if you're not using a calculator or anything like that. So anyway, we got our value here. So it's going to be 6. All right, now I'm going to erase this because I don't have a lot of space on this app program, whatever you want to call it. So now I'm going to go ahead and plug in the next number, which is negative 3 on our list. Negative 3 times negative 3 is going to be 9 minus, and then 2 times negative 3 is 6. But watch out for your sign. And again, I'm going to combine both negatives together. You're just less likely to make a mistake, in my opinion, because if you go 9 minus 6 and then minus 2 again, you know, you're switching your signs a lot. So negative and negative make a bigger negative. Negative 6, negative 2 is negative 8. So this is 9 minus 8, which is 1. And now we have our number here. And again, if I was writing this on a regular piece of paper, I wouldn't bother erasing it. But let's go ahead and put in negative 2 in here. And evaluate it. So negative 2 times negative 2 is positive 4. 2 times negative 2 is negative 4. So minus 4 minus 2. Okay, so put my two negatives together. Negative 4 and negative 2 is negative 6. So it becomes 4 minus 6, which is negative 2. Okay, now let's go ahead and put in 1. Okay, negative 1. I'm going to go ahead and turn that off for us. Give me 1 second. And negative 1. So negative 1 times negative 1 is positive 1. 2 times negative 2. I'm sorry, well, it would be negative 2, but 2 times negative 1 is what I meant to say. Looks like we're subtracting quite a lot. This would be 1 minus 4, which would be negative 3. And again, parabolas have these steps in them. And maybe now I'll go ahead and explain a little bit about the shape of the parabola when I get a second here. Maybe when we start graphing it. All right, next number we're going to have is 0. So put 0 in there, 0 here. 0 here. So 0 squared is 0. 2 times 0 is 0. And 0 minus 2 is negative 2. And again, axis of symmetry means it's going to be the same on both sides. Okay, 1 square. And 2 minus 2 is 0. So this would be 1. And let's go ahead and move over to the next one, which is 2. All right, 2 square is 4 plus 4 minus 2, because 2 times 2 is 4. And let's see, we got 8 minus 2, which is 6. All right, now we have enough to graph our graph. So we need to take, let's just start from the top. So negative 4 up 6. Negative 3, 1. Negative 2, negative 2. And negative 1, negative 3. Now, earlier I was talking about the pattern. So there's a way that you can kind of tell if a parabola is not the correct shape. And here is one of the really good ways to see how it works. So if I start from the vertex, the next point over is going to be 1. So 1 space in height from here to there. From this point, it's going to be 3. So you can see that there's 1 over, 3 up. And the next one should be 5. So over 1, up 5. And the next one would be 7, 9, and so on. So it goes by odd numbers. So 1, 3, 5, 7. And that's one way you can kind of tell if your parabola is not the right shape. So 1, 3, 5. And we have to do our best to graph it. Now, I noticed that my tool set here does not have a dash line graph. Oh, which is sad because now that means that either I have to draw it or show. Okay, I'm gonna just draw it because I would like to have a tool for it like I've been doing for the other ones, but I just don't think it's gonna work the way it's supposed to. Anyway, let's see. I'll just continue using purple for this one. Now, last thing we got to do is shade it. So remember, to shade it, we have to look at this mouth direction thing. And for that, we are going to need to remember that if it's facing towards the Y, that means it's opening towards this Y up here. So that's the top part of the graph that is shaded. All right, not the best, but it'll work for what we need it to do. And there we go. So that is the first one down. And just a reminder that this is the solution area, or that's what I call it at least. And the solution area is the area that if you pick anything in that area, it will be true. So if I pick, say, over 1 up 5, that is going to be a solution. It will be true when I plug it into this thing here. The mouth will be open towards the bigger number. And anywhere on the outside is not. And the reason we use a dash line is because you can't pick an area that is right on the line. So just as an example, if I were to pick 1, 1, or sorry, that's not 1, 1, that is 2, 1. If I were to pick 2, 1, I would get something that looks like this, which is 1 is greater than 1, which is a false statement because there is no or equal to. And that's why we use the dash line, because that dash line tells you that you cannot pick something on the line itself. All right, so anyway, let's go ahead and move on. So first thing with this one here is let's go ahead and check if it's in order. Squared 1, 0 power. So it's got to be in descending powers. And we are not missing any of them, so that makes it work out for us. So let's go ahead and find the axis of symmetry. So I'm going to go ahead and take 4, but remember, it's got to become a negative 4 over 2a, so 2 times negative 1. So 2 times negative 1 is going to be negative 2. And in this case, we can divide it. So negative divided by negative is positive. So we know this next step is going to be a positive. 4 divided by 2 is 2. So there we go. Now we know that our vertex is going to be at 2. All right, now we start evaluating it. I'm going to move up here, and I need a new function. Actually, you know, I'm not sure if I can, maybe I can save some of it. Okay, so let's go ahead and fill these in. Actually, let me, oh wait, it's supposed to be negative here. So negative x squared plus 4x minus 1. Okay, so that looks a little bit better. And I'm going to plug in -1 because that's at the top of the list. All right, here. Now remember, this negative on the outside is not affected by the square. So if we follow our order of operations, the PEMDAS, well, we don't count these kind of parentheses because they are not grouping symbols. Since they are not grouping symbols, we move on to the next one. So that would be exponents. So the power, so in this case, we got to use the 2 power. And this counts as multiplication, this negative out front, because that's times -1. So remember, if you don't see a number in front of that coefficient, you assume that it's going to be 1, or it is 1 actually, you don't assume. So we do the exponent and then multiply it by -1. So -1 times -1 is +1. All right, so we get +1, but there's a negative right here, and that negative is going to jump onto the number. So 1 becomes -1. -4 minus 1. There we go. Now evaluate it. So it looks like we got all negative numbers. Yeah, that looks right. So in this case, it would be -6. All right, on to the next one. And again, I'm just gonna erase it because I don't have a lot of space to write my write these down. But for the homework, you could probably just write these on a separate piece of paper. All right, 0 squared is 0, and you can't make -0. So let's move on to the next term. 4 times 0. Okay, 4 times 0 is 0, and 0 minus 1 is, well, -1. Okay, that was an easy one. Let's go ahead and move on to the next one, which in this case would be +1. So same thing here. 1 squared, right, that's going to be -1. 4 times 1, so this is going to stay 4 because anything times 1 is going to be that same number. And in this case, it looks like we have -2 plus 4. So -2 plus 4. And that would be +2. All right, next number. Sorry. 2. So 2 squared is 4. So this would be -4 plus 8 minus 1. So I'm going to put my 2 negatives together. So this is -5. So 8 minus 5 is 3. And 3 is the next number, so plug in 3. All right, 3 squared is 9, but again, it's going to stay -9, even though normally when you multiply 2 numbers of the same to each other, they always end up being positive. But again, it's just outside negative, just makes everything negative. 4 times 3 is 12 minus 1. So this, I'm going to put my 2 negatives together, so it becomes -10. 12 minus 10. So 12 minus 10 would be 2. And again, that's what we expect to see. We expect to see that it's going to be mirrored to both sides. Delete those and put in 4. So 4 squared is 16. So we get negative 16 plus 16. Now this is already going to cancel each other out. You have the same number, but opposite. So that's going to cancel them out. So we're going to get negative 1. Last number we have is 5. So 5 squared is 25. So negative 25 plus 20 minus 1. Now let's see, put my negatives together and we have negative 26. So 20 minus 26 is negative 6. And there we go, we have all our points. And I think I'm going to use a darker color for this graph. So maybe I'll try purple. Negative 1, negative 6. 0, negative 1. And remember, there's going to be a 5 difference. So as we approach the vertex, it's going to go 5, 3, 1. So 1, 2, so up 1 over 2. And you notice again, there's a space in here that's 3 units apart. So that's good. Over 2, up 3, and there's 1 unit apart. So again, 5, 3, 1. Or 1, 3, 5, 7, 9, and it increases by odd numbers each time. But this only works if you don't have an a value other than 1. Yeah. So if this is 1, it's gonna have that same shape. And let's see, over 3 up 2, over 4, negative 1, 5, negative 6. Now for this one, I can go ahead and use the tool because I need a solid line, not a dashed line this time. And I'm going to make this right through there. I'm going a little bit over as well, just so that way it goes through more of the points. Oops. I could make it more symmetrical. It's going to bug me a little bit. Okay, close enough. Now I'm going off the graph because the way this thing is shaped, it's kind of hard to go through all of those points because this thing kind of wants to make it. It's not really. It's more for like making circles or something. It's not really the right kind of tool for that. It makes different things. It's not designed for parabolas. All right, now we have to shade it so the mouth is open away from the Y. So away from the top means the bottom. So I'm going to go ahead and shade it along the bottom. There you go. So it's going to have the bottom shaded. And this is going to look different depending on which way it's facing. So with parabolas, you know, they can open up, open down. So sometimes it's not necessarily going to tell you whether it's the outside or the inside. So you just have to kind of go step by step. Okay, next group. Okay, now that pattern I was talking about, that 1, 3, 5, 7, it's not going to work with this one because we have an a value that is other than 1 or negative 1. So this one is going to grow, well, okay, it would grow a lot faster, but what we would actually call it is we would call it the vertical stretch. So this is going to be a much narrower graph. But let's go ahead and start working on it. So that'd be negative 18. So that's our b value over 2a. So we got to use our axis of symmetry formula. So this would be 2 times my a value, which in this case is -3. So -18, -6. So 18 divided by 6 is 3. So that's our middle number. And now I just got to pick some numbers above and below that. Okay, now we have to start evaluating at these points. So -3x, -3x squared plus 18x, but I don't need x, I need a parenthesis in this case. So parenthesis, and let me make it a little bit bigger so I can write stuff in there. -22. Now I'm guessing some of these will be off the graph, so we won't have all of them on the graph. So let's see what we get. So 0 squared is 0 times -3 is still 0. So 18 times 0 is 0. So these two are going to be 0. So 0 plus 0 minus 22. Well, it's going to be -22. So like I said, some of these are going to be off the graph, off the visible parts of the graph. There we go. Now on to the next one. So the next one is going to be 1. 1 square is 1 times -3 plus 18 minus 22. And I have two negative numbers, so I'm going to combine those first. So that would be 22 and 3 would be 25. So 18 minus 25. 18 minus 25 is 7. All right, that one looks like it probably will be on the graph. And 2. So 2 square is 4. -3 times -4. -3 times -4 is going to be -12. It'd be -12 plus 36 minus 22. And let me go ahead and put the negative numbers together. So in this case, it becomes -34. Okay, so 36 minus 34. 36 minus 34, that'd be 2. And this would be 3. All right, so let's see, 3 square. 3 square is going to be 9 times -3. So that'd be -27. And 18 times 3 is 56. Let me double check that. 18 times 3. 54, okay, I was not right on, but I knew I had to check it. Okay, now I have 27 and 22, so I'm going to put those together, 27 plus 22, and that's 49. So 54 minus 49, and in this case it will be 5. So we got some big numbers coming up. Probably nothing we can't handle. 4 and 4 here. So 4 square is 16. And 16 times 3, 48, so negative 48 plus 18 times 4. Is that really what it is? Okay, no, I must have pushed the wrong button somewhere because I got something that was way off. Okay, let's see, 48 minus 22. Oh, no, 48. And that would be 2, which is pretty much what we expect because, again, it'll be symmetrical on both sides. Now, in this case, that pattern that I was talking about, again, it doesn't quite work. There are some ways you can kind of get that pattern, but in this case, we just got to be extra careful. All right, so make sure we don't make any mistakes because we don't really have a way of checking it. 5 squared is 25. 25 times negative 3 is negative 75. And this would be 90 because half of 18 is 9 and double this number, it's 10. So 9 times 10 is 90. Okay, and 90. And we get negative 7 here. And this one's going to be off the graph, so it wouldn't make a difference if it was wrong. It's not going to change the shape of the graph or anything. So I'm going to just assume that that last one is going to be the same as the other side. So let's go ahead and start graphing. Start with our axis of symmetry, which is here at 3. And I'm going to go ahead and use, what color was I using the last time? I'll go ahead and just use this color. So I can't graph at 0 because then that would be negative 22, which would be way down here. So over 1 down 7. Okay, and then over 2 up 2. Over 3 up 5. Over 4 up 2. And 5 negative 7. And again, this is going to be a weird graph, so I'm going to try my best to connect all these spots. And it's going to be a very narrow graph as well. And it would look something like that. That way it goes through all the points. That one was a little bit better. Oopsie. All right, and like I said, I'm only going a little bit beyond this because that's the way my my computer works out. The graphing tool, it works out that way. So you got to go a little bit past it to get the shape just right. So that way it goes through the other points on top as well. And let's go ahead and, okay, so we do need solid lines for this one, so that's right. But now we have to shade it, so again, we want to shade it on the top because it's the side with the Y shaded towards the side with the Y on it. Okay. Okay, that's a lot to shade. But shading the entire thing outside is just, yeah, it's a lot to shade, but that's what it's going to look like. And again, because this -3 or anything, the higher that number gets, the narrower the graph is gonna, the parabola is gonna get. So be careful with that. And again, we don't have that same pattern of going on. So we just gotta assume that this is the right way. Now remember when I was talking about making sure that you have it in standard form? Well, in this case here, moving on to the next one, we are missing one of the values. So missing one of the values means, well, we can't have it be in the exact order. But since, well, we have x squared, so we have this one, and we have a regular number, so we have this one. So that means our b value, this one here, is the missing number. That's the one that's missing. So if it's completely missing, like it's all the way gone, not like this thing, because it's not all the way gone. If it's all the way gone, as in there's nothing there, it's going to be 0. So my b value is 0. And it doesn't really matter what my top one is, because this means my axis of symmetry is going to be right here in the middle. It's going to be right along the y-axis, which makes plugging in numbers pretty easy for it. So I put 0 in the middle, -1, -2, -3. So I just got to pick some numbers above and below that. Now I have to start evaluating. And in this case, I don't really need anything much else except this sort of looking thing. So x squared plus 6. So we only have to plug in one number, -3. So -3 squared is 9. 9 plus 6 is 15. Excuse me. And next number in this case will be -2. So -2 squared is going to be 4. And 4 plus 6 is 10. And let's put in -1. So -1 squared is, well, 1. 1 plus 6 is 7. 0, okay, so 0, you can square 0, you can multiply 0. It's always going to be 0, so we're going to have 6. So those two are kind of easy. We could just sort of do those in our head. If you want to, go ahead and keep writing them out. 1 squared is 1, so that's going to be 1 plus 6, which is 7. And now we have 2, so 2 squared is 4, so 4 plus 6 is 10. And 3 should be the same as -3, because when you square it, it's going to turn positive anyway. So if you were looking at the very first one we did here, it should be exactly the same here. So if you're a little bit smart about that, you can save yourself some work. And we end up with another graph. Now we can't, I don't know, I think these numbers only go up to 8. So we're only going to have these 3 parts here to graph. So from here to here. So -1 up 7, 0, 6, and over 1 up 7. And it looks like we have a very small graph. Like that graph is just like the parabola is way at the top and it's opening upwards. So since it's opening upwards and it's near the top, we're not going to see much of it. Okay, now if you were able to scroll up on that graph, you would see more of it. But let's go ahead and graph it anyway. So we need a dashed line for this one. So dashed line again, because we don't have the or equal to. So we can't pick any area that's right on the graph. Here, I'm going to get the side that I need to shade it on, so it's facing away from the y. So that means we need to shade it downwards. And again, this doesn't really give you much information to tell you if you shade on the inside or the outside of the parabola. It only tells you if you graph the top or the bottom side. So we have a lot more stuff to graph for this one here. And we shade the entire bottom side, which is all of the outside of the parabola. Okay, so that's it for this one, I think. Ooh, this heater has my eyes a bit dry. Interestingly enough, we had snow, a little bit of it here in Tuba. I got out of the door a little bit later because I wasn't expecting the snow and the frost on the windows. And now, like, it's that time of the year to break out your heater, and now it's like going to be the time of itchy eyes now. Anyway, so again, check the order. So it doesn't really say that on the directions from this, but if we check the order, we are missing one of the terms again. So we have our x squared, so we have this one. We have the x, so we are missing the c value. This last number is what we don't have. So this doesn't affect it doesn't affect much else. It doesn't affect like the axis of symmetry or anything like that. So, okay. This is our b value, which is already negative, so we would have opposite of negative, so we end up with a double negative. 2 times negative 2. All right, that does look a little bit confusing. So opposite of b, which again, b is negative 2, so that'd be positive 2 over negative 4. Continue dividing, so we cannot divide 2 by 4, so we are going to have to reduce it. So divide each of them by 2, and we get negative 1/2. So as we make our axis of symmetry, it's going to go right through here like that. And now we have negative 1/2, and we need to pick values above and below it. So the next value, so looking at the graph, there's negative 1/2. Go down, we get negative 1, negative 2, negative 3, 0, 1, 2. All right, now we can start evaluating for this here. So negative 2x squared minus 2x. And we don't have any other number, so we're just going to go ahead and leave it at that. So plug in negative 3. And now we're going to have to evaluate it. So again, use your exponents first. So negative 3 times negative 3 is 9, and 9 times negative 2 is negative 18. Negative 2 times negative 3, so negative times a negative will be positive, so this would be negative 12. And that's our first one. Continuing that procedure, we go to negative 2. So negative 2 squared is positive 4. Positive 4 times negative 2 is negative 8, so plus 4, because negative times negative is positive, and this would be negative 4. Next one is -1. So -1 squared is +1. Negative times negative is positive. All right, now for this next one here, we could probably put in -0.5, or maybe we could do half. Just for calculation, I think it'd be easier to say -0.5. All right, I'm going to write it a little smaller, but that's supposed to be a negative. Now, if you square a negative, you could just use your calculator. And that would be 0.5 times 0.5. Or if you do fractions, you can go 1/2 times 1/2, and that would be 1/4. But again, it's a little bit easier to calculate it using decimal. So in this case, it would be 0.25. And if I double it, now that's like a quarter, right? Half of a half, so if you have half $1, which is 50 cents, and you take half of that, that would be 1/4 or 25 cents. If I double it, so double 25 cents, that would be 50 cents. So I know it's a bit confusing seeing like, hey, wait a minute, how did you get that exact same number back out? All right, but if you calculate it out, that's what it comes out to be. And here, negative times negative is positive. So that'd be 2 times half, or half of 2. So that would be 1. And this would be just like 1 minus 1/2. So in this case, it would be 0.5 or 1/2. Ooh, okay, again, a bit tricky. All right, 0, plug in 0, that's gonna be super easy. 0 squared, 0 times anything, always gonna be 0. And I don't have any regular numbers. So if I had any regular numbers, it would just be those regular numbers, but in this case, we don't have any. So it's gonna be 0 all the way. All right, let's go ahead and do 1. So 1 square is 1, and 1 times -2 is -2 minus -2, or minus 2. So this would be -4. And this last one, again, is not on the graph. So it doesn't make a big difference whether or not that, if it's not the right point, it didn't matter because it's not going to be on the graph anyway. Okay, let's go ahead and start graphing it now. So again, this is not going to be on the graph. So -2, -4, -1, 0. Actually, I miscalculated it from here. So it would be 1 more space over. And then -1/2 up half. So it'll be right there in the middle. 0, 0, and this one, as long as it's the same on both sides, so over 1 down 4, which it does look like it's the same on both sides. We do have it a little bit stretched, but it's only because the axis of symmetry is in between two numbers that it looks kind of like a bit of a problem, but not a big problem. And I need to check the kind of line that we need to use, which in this case has the or equal to. So since it has the or equal to, that means we are going to need to use a solid line. So solid line is the correct one. Now, let's see, we got to shade the right side. So the inequalities mouth is facing away from the y. So that means we shade the bottom side. So inside of the parabola, or the bottom side. Now, just to kind of help you out, I usually kind of show you these on other graphs as well. So I might switch over to Desmos really quick. Let's see. There we go. And you can graph inequalities on Desmos as well. So why, I'm not sure, now I should have taken a better look at it. I'm not done with this just yet. Oopsie. Okay, I got to make sure it goes on the outside, but otherwise you get a whole different kind of problem. And you notice that it's already kind of taken shape how we need it. So 1/2 square, negative 4x plus 12. And that b value causes it to move kind of sideways and downside. And if I add 12, that's going to move the graph upwards. So each of these things kind of moves the graph this way, that way. Okay, so once you get the hang of it, you can kind of look at it and tell that it's going to be a little bit on or off, or something doesn't look right. Now with this one here, you can spot our axis of symmetry. So in this case, the axis of symmetry is 4. So if I want to make an axis of symmetry, I can go x equals 4, and that makes that blue line that goes up and down. And I just need to pick a few x numbers. X equals 3. X equals, oopsie, next one. X equals 2. And x equals 1. And now I have 3 lines that allow me to pick my values. And I can just click on them, and that will highlight those values. So I can easily see now where my numbers need to be. So if you are stuck on these, you can use Desmos, or you can use it to check your work. And since you're watching this video, I'm almost certain that you would have internet. Again, you just go to Desmos, and it's the easiest way to graph it, because you can just type in the formulas, type in your functions, whatever you need. So I'm going to go ahead and graph this one. So let's see, the vertex was at 4, and that means that we need to go 3, 2, 1. And you would just multiply this together. So just if you wanted to do it, okay, so opposite of b, so negative b, take away the negative, or opposite of negative, you're going to end up with a double negative like this one. So that would make positive 4. And then over 2a, so 2a is 2 times 1/2, which half of 2 is 4. Sorry, this stays 4. Half of 2 is 1, so 4 over 1 is 4. So you would still get the same number. Like, you would still get the same number that we did on Desmos. So I know it's over 4 up 4. And you would also plug these in. Now that might be a little bit tougher with the fraction, but just remember, you just take half of whatever number that is, and you could also turn it into a number. So hopefully we got our numbers. So all I showed you here was how to get the axis of symmetry, but we already have that. We already know that it's at 4, 4. So 3, and we had 4.5, 4.5, 2, 6. And again, it's going to be the same on both sides, however you look at it. And 8.5, 8.5. Okay, now let's get back to graphing. So over 4.5, Now this one is going to be horizontal, or it's not horizontally, vertically compressed, so it's going to be squished. So your graph is going to, it's going to be half as much. So essentially what you're doing is you're squishing it to half of what it would normally be. Over 6, up 6. So if you remember that pattern I was talking about, it's going to be half of each of those. But again, you don't really need to know that too much because we are going over. Now, I'm just graphing this just to show you that 8.5 would be up here. Oopsie. Go ahead and label this. Did I go a little bit further off? Well, actually for this one, we are going to need a dash line because there is no or equal to on this inequality. So I'll do my best to draw a dash line between each of these points. Ah, there we go. I should have made it a little bit more curvier, but oh well, best I can do. Now we got a shade. It looks like in this case it would be the top of the side. So since it opens upwards, we got a shade up here. Aw. Anyway, that's it for this one here. So looks like we are pretty much done. Okay, so I guess that's it. Let me go ahead and let me tell you what else is going to happen this week, because there are going to be a few different things happening this week. So, and that's it for today. I will be around for another minute if you have any questions. If not, then I will see you later. Okay, bye-bye.